Hey everyone, in this video we are going to see how you can deploy your applications on Kubernetes cluster. If you don't know how to containerize your applications, we have already made a video on it. You can check that out. The link will be in the description. So let's get started. Okay, so as we start with Kubernetes, there are some things we need to know. So I won't be going totally deep into the topic, but I will give you a brief overview of what Kubernetes architecture looks like and what you need to know in order to get started with Kubernetes. Or if you are a beginner and getting intimidated by all the technical stuff, I will try to simplify that for you. So when we are trying to work with Kubernetes, there are some things we need to know. So Kubernetes, what is Kubernetes and what is K8? So when we write Kubernetes, so there are 8 letters from K to S. So that's why in short form it's called K8s. So the first thing is we need to know what is Kubernetes first, right? So Kubernetes is known as container orchestrator. So what is container orchestrator? As in the previous video, we have saw that we have a lot of containers which have our applications running, something like this, right? Something like this. When you deploy your application, what if there was some object or something that manages everything that goes into your deployment and making sure your application is live every time, right? So that's what Kubernetes does is it it tries to be that one thing, that one specific middleman that tries to and keeps your application going, right? So what is orchestrator? So orchestrator, if you have seen the orchestra, then there is an orchestrator which tries to manage and tries to run the like music and orchestra smoothly, right? So that's what the Kubernetes does. So when your applications are running in here and Kubernetes tries to manage and keep track of what's going on, if there is problem or anything like that, and tries to manage your container. So that's what it's called as. That's why it's called as container orchestrator. But Kubernetes is much more than just the orchestrator, right? So what are the more features? So again, there are some feature like zero downtime. What does the zero downtime mean? So suppose your app is running 1.0 version, right? And you have like major changes and now you have 2.0. What you will generally do is you will remove these containers for 1.0 version and reinitiate 2.0 version containers, right? But what does zero downtime means is that it will do rolling updates, which means say suppose update your containers in such a way that the customers or the people who are using your application don't face any downtimes or your application is running every time. So there is zero downtime. So there is literally no downtime to your application. Yeah, so apart from that, there are many more features to Kubernetes. Kubernetes helps you to scale your applications. So which means that say suppose you have 100 users right now. You have 100 users right now and your application is working completely fine. Say suppose your application gets 100K users, the infrastructure, whatever you have implemented for 100 users, won't be able to work for your 100K users because it will fail and it will be much lagging and there won't be it won't be as smooth as it was working for 100 people. So it can scale up and scale down according to how your application is getting the traffic, right? So if it gets say suppose 100K, then it will scale up, and if it again goes back to 100, then it will scale down. So this is what auto scaling means, or it scales automatically, and that is very smart feature to have actually. If your application is running say suppose on Google Cloud provider, right, and now you want to switch it to AWS, with Kubernetes it becomes really easy. Then it runs on most and all the cloud providers, so you can actually put your application, you can run your application on cloud providers. Not only cloud providers, you can actually run your application on your local machine as well, or your own cloud, right? That is possible. You can actually do everything you want. The architecture change, but you can create volume. So What are volumes? Volume is you can consider it as like a database for Kubernetes. And there is load balancing. So it's very beautiful feature that say suppose you are having traffic of say suppose 100 users right now, and so it's distributing it accordingly to the containers and pods running. I will tell you what all these pods and etc mean in Kubernetes in just a second, but let's see what load balancing means, because we will be working in a demo. We will be creating load balancer. So what does that mean? Say suppose this application right now is running and this container is handling good amount of people, so good amount of people are using your application. A new user comes, say suppose I come to your application and it goes to the Kubernetes load balancer. It sees, hey, this already has a lot of things going on, but this is currently kind of empty. It doesn't have that much load, so let's redirect Kaiwalya to this. When I come here, it I will get redirected to you. And then similarly, if other people join, uh, the Kubernetes load balancer and Kubernetes will smartly load balance, so it balances the load that comes to your application. So this is like the basic what is Kubernetes and what are the features. Right now, I just mentioned all the terms you are already aware of, so like containers, and then in general term, even if you don't know how the deployment goes around or anything like that, you can still wrap your head around that zero downtime. That means my application won't be down anytime, right? So it will be live 24 by 7, right? Then what are cloud providers? Cloud, we are always hear about Google Cloud, AWS. We don't know how that works or how applications are running on that, but we know that there are clouds and applications are running on them, right? So we can imagine that if we are running our application somehow on Google Cloud, we can migrate it to AWS or any other cloud provider we want, and we can put our application on our Kubernetes application on a cloud provider or our local machine or our own cloud as well. So that's possible too. So we can imagine this in a similar way. So there is no technical terms coming in right now, which we will be heading into them after this, right? So these are all the like not all the features, but main features of Kubernetes, and that's why Kubernetes is not just a container orchestrator. It's not just the container orchestrator. It does much more than container orchestrating, and these are the majority and the important features that highlight the importance of Kubernetes. So let's get into simplifying the architecture for you. So I won't be going totally deep as I mentioned earlier, but I will let you know the more specifics and the terms which we generally use while working with K8s. So the first thing we generally mention is kubectl. So this is like a command line tool if you want to work with Kubernetes. Cool. Then there is a control plane. Okay. Then there are worker nodes. Cool. Then there are container runtime. In container runtime, we have pods running, and each pod have containers running. Right now, if you have followed the previous video on Docker and containerizing your application, you are already familiar with containers, right? So you know what container is. Your application is running inside the container, right? And now we will see what all these things are. Works? Cool. Now let's see this in a diagrammatical format, right? So there is a user, which is us. Okay, we want to deploy our application to Kubernetes, right? So we want something to work with, right? So we want something. So there is kubectl command line tool, kubectl. We install kubectl and put in some commands we will see in bit, and we work with it, right? When we go to kubectl and put all the commands, it gets connected to, like, it's connected to control plane. We don't know what goes inside it and anything right now, and we don't need to worry about that, to be frank, right? Then it goes to control plane, and then control, there are worker nodes. So worker nodes, there are worker nodes, which are connected to control plane. Okay, in worker nodes there is a container runtime. What is container runtime? We know container, and to run container, generally what we use Docker. So in general sense, you can Docker is one of the container runtime, but Kubernetes uses some other runtimes. We will see them in the future, but you can imagine it as like Docker. To run containers, what we need? Runtime, right? So here we can consider it as Docker. So there is container runtime. After that, there are pods. There are pods inside container runtime, right? And inside pods, there are containers, right? Now, as you might have guessed that we already know about these containers. These are container runtimes. Then this is pod, this is pod, and this is container. Cool, container runtime. Okay, now, like, little bit of theoretical definition. Pod is the smallest configurable unit. So when if you are working with uh, Kubernetes, the last thing, the smallest thing and the least thing you can configure and customize is pods. So the configurable smallest configurable unit, right? And worker node, obviously this is like a rough architecture. There are much more things, so there goes many things in control plane as well, many things in worker nodes, in container runtime as well, everything goes. But now we will be simplifying it, so I will only tell you that much which you need to know and to understand what we are trying on in that commands and etc. So that's why, according to me, this is the basics I'm trying to teach you. Cool. And this is a little bit architecture. So every pod has generally one container running. You can actually run many containers inside single pod, but generally there's only one pod running in one container running in one pod, right? What is replica set? So there might come sometime there, you mentioned replica set. Replica set means what is mean by replica? Replica means duplicate, right? Duplicate or duplicates. So you give rules to your Kubernetes. So say suppose there is a rule that says every time there should be three pods should be running. I don't know what you do, but every time three pods should be running, right? So these are called replica sets. These are called replica sets. So Kubernetes will always keep a track on if there are three pods running inside your cluster. And what does the cluster mean in this sense? So whatever is here, right? So if we just put big box around it, so this is your cluster. So you use kubectl to connect to your cluster, and everything else is in this cluster. So when we say cluster, Kubernetes cluster, so it means this. And you can obviously you can create as many clusters as you want on single cloud provider or different cloud providers, and every cluster will have all these things inside them as usual to make it manageable, and you can connect your kubectl to all these clusters. It will always check if there are three pods in your cluster, and that's called as replica set. And say suppose if one of your pod goes down, and Now, out of three, there are only two pods running. So Kubernetes will reinitiate a pod. It will reinitiate a pod. So it will take down this pod and it will reinitiate a new pod, which is running your container. And now it ensures that there are three pods running again in your cluster. Cool. So that's how you go to zero downtime and it self heals. So that's one of the features of K8s, that it self heals itself. So whenever something goes down, say suppose container goes down, it will reinitiate container. If pod goes down, it will reinitiate pod. If entire node goes down, it will reinitiate the node. That's how it goes. So that's called as self-healing, and this is literally the terms you need to know. So what is container, where your application is running? What is pod? It is like smallest configurable unit where your containers are running. So to manage the containers, it is a manager of containers. Cool. And to manage the pods, there is a node. To manage the nodes, there is control plane. And where is everything? It is in cluster. And how do you access that cluster? Through kubectl, which is a command line tool. And we will be looking that there is a IDE called Lens for Kubernetes, which is absolutely great. I love it. We will be making a separate video on it. So make sure you subscribe to the channel and are in the loop. Cool. So this is the architecture. Now let's go ahead and try some hands-on demo. Okay, so for this video, we will be using application, a containerized application already. So we make devs. So we will be deploying we make devs website on Kubernetes cluster. And from the previous tutorials, we have already containerized this application. So let's go ahead to hub.docker.com and you can actually see we have a built image. I will have to log in quickly. So you can see we have already an image on our Docker Hub. So now we will be deploying the containers and we make the website on Kubernetes cluster. And for this tutorial, we will be using Linode. So you can actually do that on a Minikube as well. I will be demonstrating it on Linode. Perfect. Now we will create a cluster on Linode. So if you go to Kubernetes, we can create a cluster. Okay, there's a manage downtime. Okay, what is the cluster label? So WMD demo website. We can put something like that. Then we can select the region mobile, which is closer to Kubernetes version as it is. Then we will take three nodes. So when they say this, it's three nodes. So add, okay, works. I just click the create one, create. Okay, so now as you can see, it's provisioning and like all the details of your cluster. So this is our cluster name. The kubeconfig, this is the important thing. What is kubeconfig? Here we will quickly see what is kubeconfig. Cool. So when you are working with clusters, right? How we will connect? So cluster creates something called kubeconfig. Cool. And you copy this kubeconfig file and add it to your kubeconfig file, kubeconfig file, kubeconfig file on your local machine. So now kubectl, whenever you say, hey, create your application or do this, do that, it will check what cluster you are trying to go, and it has all the authentications and etc. to connect to your application. So whenever you create a cluster, you get a kubeconfig, and say suppose I create a cluster and you want to work on it, I will share the kubeconfig file with you. You will like configure the kubeconfig file, and then your kubectl will be able to access my Kubernetes cluster. So this is really important. Usually you don't share this kubeconfig with anyone, or else they have the access to your Kubernetes clusters. And this is how you connect your kubectl to your Kubernetes cluster. Cool. I hope our Kubernetes cluster. Okay, so now you can see the kubeconfig is ready. and we can actually download it. I will quickly go on view, and then we are inside the repo. No need to see what all things are going on in here right now, but we will go ahead and configure the kubeconfig file. Good. So let's go ahead and code. I open kubeconfig files. Generally, this is the path. You open, so open here, and now this is the kubeconfig file, my earlier kubeconfig file, which is not working, and then paste the new kubeconfig file. So this is the kubeconfig file. Okay, cool. So now our kubeconfig file has been added, clear, and it's saved. So let's remove it. And now let's check if our kubectl is connected. How do we do that? Kubectl git boots, right? So let's wait a minute. Right. So now we have the nodes which say LKE, and how do we verify that? If we go back here, we will be able to see one is running and two are still provisioning, so we are able to see that, and afterwards we will be able to see all of this. Cool. There is one more thing which you need to know, which are called manifest files or Kubernetes manifest files. Okay, so what are those? Awesome. So what we have seen until now is two types of files. First is uh, kubeconfig file, which is used to connect your cluster to your kubectl. The second file which we are going to see are manifest files. Manifest files. So what are manifest files? So manifest files are the rules or the steps you decide that how your application should run. So as I said earlier that for replica sets you mentioned there should be three pods that should be running at entire times. Where do you specify that? How do you tell that? So you create some manifest file which are in YAML format. So they are YAML files, and you mention the name of your deployment, the replicas that should be running, and everything like that. The ports, and if you have watched the Docker video, I have mentioned, I have explained what ports are and what port forwarding and how it works. So it's the same here as well. And so the manifest files are the rules which you define that how your cluster should function and how it should work, right? And there is one more concept which I would like to tell you is deployment services. So you know what are pods, so you know what are nodes. There are other things which are called as deployments and services. Deployment services, cool. There are obviously different types of services which I won't go into depth because we want to deploy our application to Kubernetes without worrying about all this complexity, right? But you should be knowing deployment is, you can consider it as an object, Kubernetes object. What is deployment? Your application is running here. Application is running. That's your deployment. Simple terms. But what is service? Service is kind of a middleman which you need, right? So you can consider service as a middleman. So service talks to you. For every object, you need to create a service, and the role of service is that if you want to talk to this deployment, you need to go to its service, then service picks the deployment and you get whatever output you want or configure it whatever you want. But without service you cannot access this deployment. So for that you create services. So whatever you have, say suppose you have website running in here, the front end of the website. If you have back end of the website, which is another, you have a different backend, right? So this is, say suppose, deployment for your backend. The here is running your backend application, web backend. Cool. Now you want your front end to talk with your backend, right? So you cannot directly connect as you do on your local machine. You will have to create a service which talks to your backend, service which talks to your front end, and now your front end will talk to service of your backend. Backend will work, give its output, and everything will work like that. So you get how it's working, right? So in simpler terms, whatever components are there, so front end is one component or object, back end is object, database is object, right? So your MongoDB or etc. So these are called deployments or objects. Deployment is one of the objects of Kubernetes, and you need uh, services to talk to this. So only the services can access this, and there are types of service like cluster IP and load balancer service and other services which we won't go in depth. If you want, you can search on Google, and there are Kubernetes documentation as well, which you can see. Okay, so when I mentioned Kubernetes docs or Kubernetes docs, so you can actually see a very good documentation. Actually, you can go ahead and click on get started and learning environments, concepts. So when I mention about like services and load balancing, etc., you can understand more about services load balancing. It's very simple language, and if you know all these technical terms which I just told you now, then you will be able to understand it really easily. What are workloads, then architecture in depth, because I gave you overview. If you want to go in depth, it's there. Then containers, what are containers, container runtimes, etc., what's networking policies, task tutorials, everything is there. Cool. And now our cluster also has three nodes running. Cool. So, and every node has its own separate IP address. We don't need to go in depth for that. And our kube config is configured with your kubectl. Let's check once again, kubectl get. Right now, you can actually see the three nodes and they are ready, and the Kubernetes version that's running on there. Cool. Now let's go ahead and deploy our website to this Kubernetes cluster. As you mentioned, how do we deploy our applications to Kubernetes clusters? Through manifest, we define rules, etc. Right? So, and as I mentioned, this is the deployment and this is the service. Simple enough, right? Now let's go ahead and try to understand a little bit. We won't go totally deep into what every tag here means, but a basic overview. So basic what we can see, kind deployment. So what kind of file this is? So this is a deployment file. So we are trying to create a deployment with it. What is the name of this deployment? So WMD, we make devs deployment. I have named it this. You can name it anything you want. Labels app. So we if you have worked with HTML CSS, you know that IDs and classes, right? So the similar concept, you can use the labels to define an app or locate an app, etc. You can use the labels. Then specs and templates. So when you see a template, so the thing here is these are the rules for pod. So whatever is in template, so these are the rules for pod, and other are the different rule for your deployment overall. And if you can see replicas, here is one replica. If you want, you can do five replicas. I want five parts of my web application or website running every time, so we will do five replicas. Cool. And what is container port? So in last video we saw that we are running our container on 3000 port. So what is container port? This is container. What is the name of the container? I will put WMD container. Cool. That works too as well. And then this is a service for our object. The other service which I showed, I will again show, that is a load balancer service. You can directly connect as well, but I try to keep it more separate and specific to manage it better. Cool. Now this is the service. What does the service say? Again, kind is service. Name of the service is WMD service. Selector is WMD, which we added here, right? So it says for what this service is, we, for what object this service is. So we do it selector app. So it's the service for the deployment which we created. If there are multiple deployments, multiple services, you know how hectic it would get, right? So you can actually create these small selectors, different selectors, and map it to your services accordingly. Then protocol, port, target port, again the same. It will receive request on 3000, and the target port is 3000. Port forwarding, again simple stuff. Cool. And you don't actually need to remember, because when I got started, I got very overwhelmed with how these files are structured, and why I don't understand half of the stuff that's written there, and why it's nested inside, why it's not nested inside, everything like that. You don't need to learn this. You can actually copy it from your previous projects or this project. So if you go to vmake.dev's GitHub repo and to the Kubernetes folder, you can actually find these files. You can just copy these files entirely as it is, make changes as your own, and actually try to deploy it to your own cluster, and it will still work fine. And that's mostly how you do the things, right? So I usually copy my configs file here and there, try to tweak around that, and try to run my application. Cool. So now what we have done is the kind is deployment. uh, the names I have mentioned, the replicas I have added, the container name, etc., etc. Everything seems perfect. And then what is load balancer? We have seen about load balancer. Now this is the service that creates the load balancer. So kind of service, it's a type of service. But what is in service? What type? It's a load balancer. And if we go here, is there a type? There is no type. So its default is cluster IP. We won't go detail into what cluster IP is, but if there is no type, it's cluster IP. You should remember that. And in services, we explicitly mentioned load balancer. So when someone comes to your application, it will go to first load balancer, and load balancer will load balance it into the container which is most free or most perform on performance based, etc., according to its preferences. But now we show that 3000, what is this 3000? This 3000 is the port for your service. So this is not the container port, but this is the service port. So if the service port was, say, suppose 8080, it will, our target port would be 880. So when someone comes to 9000 port of load balancer forwards it accordingly to the 3000 port of the services which are under there. Cool. So this is load balancer is done. Our uh, deployment file is done, which has its own service, and with YAML format, this means the file separation. So it considers it as a different code, and generally we put it in the same file. If you want, you can create different files as well. That works too. But it is easier, right? So it has deployment and its service. And now if I have more deployments, I have the same deployment code, service code, deployment code, and service code. Same way. Right, now let's go ahead and try to deploy it. Right, we have our cluster running. Let's confirm it again, kubectl get nodes. Right, now we have confirmed that everything is ready and nothing is failing right now. Cool. Nice. Now let's go ahead to our Kubernetes folder. Kubernetes folder, which has our deployment and service files, obviously, right? And then what command we use is, so first, before applying, I will tell you some commands, right? So if you go to kubectl get deploy, you will see the deployments which are on your cluster right now. Cool. So when this command runs, see, no resources found, because we don't have any deployments right now on our cluster. If we put kubectl get pods, we can get pods. There won't be any pods right now, obviously, because we don't have any deployments. Again, see, no pods. Kubectl get svc or services, right? So we can see what all services are running currently. None again. Okay, so let's apply kubectl apply -f deploy.yaml. That's how you apply your manifest to your cluster. Cool. Now your deployment will be created. Let's wait for a minute. Cool. Now you can see your deployment. Deployment is created, and because the service was in the same file, your service also got created. Makes sense? Now let's apply our load balancer. Apply -f svc, but yeah. Perfect. Load balancer is also created. Now you can see, now if you again go kubectl get deploy, we should be able to see we make dev wmt deployment, the name. See, we can get the name. And what is this 5 ready? Because we have put here the replicas as 5, it shows us how many are up and how many are down. So currently all 5 are running. All 5 replicas are running. Cool. So kubectl get. So if you want to see the 5 replicas that are running, so what should be there? If you think what should be there, 5 pods should be running, right? So let's see if you can see 5 pods running. See, these are the 5 pods that are running on your cluster, and all are running, and that's why it shows fire ready. Cool. Let's see services. kubectl get services. Right now, you can actually see these are the services that are going. Let me just close this so you can actually see it, right? So these are the services that are currently running. So this is the Kubernetes service. Obviously, it's needed. Then this is a service which connects to our deployment, and this load balancer service which connects to our which communicates to our service, obviously. And now you can actually see there is a external IP here. What is this external IP and why doesn't our WMD service have it is because we don't want outer world to communicate directly with our service, right? So that might cause a security issue, or we don't want outer world to do it. But when we want everyone to access our application, right? So what we have done here is if we just check out our through graphic format, right? So what we have done right now is we have our deployment here, which is app, right? We have service for it. We have service for it, right? And this is running inside a cluster, inside a cluster. We don't want the outer world to directly communicate with our this service, right? We don't want that for best practices or security issues, anything. We don't want it. So what we did is, and obviously we created a load balancer service, and now the load balancer service was connected to your this service, right? And now we want our application to be accessible, right? So people should be able to access your application, right? They should be able to use it. So this load balancer has an external IP. So now whenever someone goes to wants to access your application, they will come to this. So this has an external IP. So external world can access your application, and now it goes to it. So it doesn't directly communicate with your service, it goes to load balancer. So outer world should be able to communicate with your application, right? So there should be an entry point, and load balancer acts as an entry point, and that's why we have a external IP here. And if we just go copy this external IP, go here, new tab, paste the external IP. And what was the port for load balancer? Let's see the port. Actually, you can see it here, right? You can actually see it here, and obviously you can also see it here. The port where everyone should come is 9000, and it will route to 3000. So if we go to 9000 port, we should be able to see the running website for we make devs on Kubernetes cluster. So this is actually running on Kubernetes cluster, and we are able to access it. So obviously you won't be able to access it if you run it like that, and my cluster won't be running until you see the time you see this video. So now we have successfully deployed our application and everything is done. We will just quickly see the ID, the lens ID, and you can actually I will be making a dedicated video on what is lens ID and how to use it. So you can actually go here, and lens ID is connected with the kube config. So obviously that's why it's able to show me all this information on my. Yeah, I will be making a dedicated video on this, and you will be able to see. So see pods are running and replica sets are there. Cool. And yeah, that's how you deploy your application to your Kubernetes, your own Kubernetes cluster. If you are doing the same steps in Minikube, it would be the same. And if you face any problems, let me know. Join the Discord server, and we will be always there. As always, I have written a dedicated blog on what is Kubernetes. So this is in depth again. So it will walk you through history, then bare metal, what are virtual container, like what are virtual machines, what are containers, what are the different types of architectures, monolith, microservices, what is orchestration, and whatever I mentioned, whatever are the features, if you want to recap them and try to implement these features and try to see these features in action, you can actually see that. Then you can go to Kubernetes cluster. What is cluster? So say, as I said, there is control plane and etc. And there are many things in that and how it works. You can actually read how that works in this blog. It is in much detail, and all the commands are listed here, so you don't have to worry about like how what was the command. I'm not able to remember it. Here is the cheat sheet for you. So yeah, that's it for this video. If you like this video, make sure you hit that like button. It really helps support the channel. If you want to stay connected with the ongoing series and all the CNCF efforts, then make sure you subscribe to the channel, and we will see you in the next one. Bye.